For the last section of our Big E Explore, we're thinking about calculating several eccentricities of objects that are within our solar system. So we know that every planet in the solar system has an orbit around the sun, and it's typically an elliptical path of varied degrees. Some are more circular and some are more elliptical, just depends on a few conditions. So what we have here is some data for, again, many objects within our solar system, and what we want to do is calculate that eccentricity, which again is describing, how circular an orbit is. You might remember our details from earlier. If the eccentricity is close to 0, it's more of that perfect circle, where if it's closer to 1, the orbit is more flattened out. Okay, so we did some calculations of this already with our specific ellipses. Here, the data is already given for you. So there's one that's already set up where you can see where the different Q's are coming from, right? The big Q is this data table or this column, where the little q is this column. And once you get those calculations completed, you are using those two new values to generate your eccentricity. And then again, observing that to see how close it is to a circle, 0, or 1 ellipse. So I was just going to do one with you here using this same structure. I've got my q, little q, which is measuring that perihelion distance, how close we are to the sun, and our big Q, or aphelion distance, how far we are from the sun. So I've got big minus small for my first column of calculations. So I'm going here, big 0.73 minus 0.72. And I want to see what that equals. And then my next column here is simply adding those same numbers together. So 0.73 plus 0.72. And again, seeing what I get there. So this is where you can pull out that calculator. Come on. There we go. So I've got 0.73. Oops. Minus 0.72. So my first number is 0.01. And now I add them together. 1.45. And my final spot that I'm thinking about here, my eccentricity, is where I divide my two brand new numbers. And I'm just going straight left to right here. So my formula is going to be 0.01 divided by 1.45. And I am asking you to show your calculations there. So I want to make sure I write those in. 0.01 divided by 1.45. And again, plug that on the calendar. And we're going to round to the third decimal place. So I've got 0.00, looking at my calculator, 6. 6 is going to, we'll have to decide what the 6 is going to do, so I look back at my 8 to tell me it will round up 0.007. There we go. And then I'll keep going. It's up to you if you want to work horizontally or do all the subtractions and then all the additions, whatever works best to get you your eccentricity numbers or variation from 0 or from a circle from your orbit. Once your data table is complete, you're using your values to answer these this number 21 and then kind of pulling it all together here in 22 and 23. As always, reach out through Schoology with any questions.